Hey fam, these are our solutions for quiz 9. If you are intending to retake quiz 9, this will be a really good refresher to get you ready for that, but also to help get you ready for your comprehensive exam for Unit 3. So as we go through and talk about these problems, anything that I know will be on the comprehensive exam or on the retake for quiz 9, I will make sure that I try to highlight throughout these questions. Okay, so let's get started. I want to start on the back questions. So I want to start with number 4. Number 4 says, at a small coffee shop, the distribution of the number of seconds it takes for a cashier to process an order is approximately normally distributed with a mean of 276 and a standard deviation of 38. Which of the following is the closest proportion of orders that are processed in less than 240 seconds? So if all we have to use on this problem is the empirical rule, what we need to do is draw our normal curve and label our standard deviations. Now, if you do not know what the empirical rule is, you need to go back through your notes and make sure that you know that the empirical rule you can use on any normal curve, and it tells you that 68% of the data is within one standard deviation, 95 is within 2, and 99.7% of the data is within 3 standard deviations. So we're going to use that to estimate what proportion are less than 240. So in our center, we have 276. Then we are just going to add 38 to get our standard deviations. So 314 is one standard deviation. 352, 390. And I really need to label my parameters on this: 276, 38. Okay. I'm adding those one more time because I'm feeling like... All right, so to go the other direction, we subtract 38. So 276 subtract 38 is 238. 200, 162. And they have given us a value of 240, which I think is about right there. 238 is one standard deviation away, and they gave us a value of 240. That is very, very close to 238. So we can estimate what percent this is by using the empirical rule. And what that tells us is that we have 13.5% of our data here, 2.35% of our data here, and a very, very small percent of our data out in the tills. I mentioned this on some of our lessons, but I want to mention it here. I think that some of you guys have the misconception that these normal curves only go out 3 standard deviations. And that is not true. There can be data that is past 3 standard deviations. If there is, it is very unusual and it is an outlier, but it is not impossible. So make sure that you know these are not end points. These are just our 3rd standard deviation away. And this picture is trying to illustrate to you anything that's past 3 standard deviations away is very unusual. Not impossible, very, very unusual. Okay, so what this means, if we add up these percents would equal 16. These percents would equal 16. So what we know is that the percent of X values that are less than 238, that's 16%. Well, if 240 is really, really close to 238, then that means that whatever percent it is, it's really, really close to 16%. So the one that is closest to 16% is A, and it does make sense that it would be bigger because look, the flag is to the right of 238. So it does include a little bit more data than just 16%. Next up is our Labrador Retriever problem. We have a distribution that's normally distributed with a mean of 87 and a standard deviation of 8. Now, if I don't have room to draw a normal curve, I'll usually just draw the x-axis on my normal curve. And then I would put 87 in the middle and then start adding my standard deviation. So this would be 95, 103, 111. This would be 79, 71, 63. And I could be wrong on those because I added them in my head. Now, if you're just doing it this way, you may want to label your middle value as mu. You could also just draw your curve up into the problem. I didn't do a very good job of getting the center of my curve over my mu though, so I should probably adjust that. Okay, about 95% of adult male Labrador Retrievers weigh between 79 and 95. No, it is not 95%, it is 68%. 79 to 95 is within one standard deviation. The median weight of adult male Lab Retrievers is more than 87. No, it is 87. The median is 87. The proportion of adult male Labrador Retrievers that weigh less than 80 pounds, okay, so that is one tick mark above that standard deviation, and more than 94 pounds, that is also one tick mark. Okay, is the same. Well, let's think about it. At the 95 to the right would be 16%. So from here over would be 16%, and I'm only 1 pound away from that. Then from 79 over would be 16%, and I'm once again only 1 away from that. And 1 away so that it would be bigger. And this one would be bigger. So similar to this problem, this might be 17 and this might be 17. But regardless, these are in the same position on the different ends of the distribution. So I'm thinking it is C. I'm thinking it is C. Almost all adult male Labrador Retrievers weigh more than 79 pounds. No, not almost all. Only 84% weigh more. Only 84% weigh more. That's not enough to say almost all. Almost all is like 99, 98. Then lastly, the standardized weights of an 80 and 94 pound are roughly equal. Well, let's check that. The Z for an 80 pounder is 80 minus 87 divided by 8. And the Z for a 94 pounder is 94 subtract 87 divided by 8. I plug that in, and for the 80 pounder, I get negative 0.875. And for the 94 pounder, I get 0.875. These are not roughly equal because one is negative and one is positive. One is negative and one is positive. So by deduction, it has to be C, but this also helps us know that C is true because look, they're in the same position from the mean, or they're the same distance, not position. I should say they're the same distance from the mean, which means that the percent below the lower bound and the percent above the upper bound would be the same. This is a really good question to verify that you truly understand normal distributions. Okay, this jigsaw puzzle we have seen quite a bit. It is very similar to the problem that we just did. We're going to have to draw a normal curve for the small puzzle. We draw a normal curve for the large puzzle, and we figure out where on those normal curves our standard, or not our standard deviation, our score is. So I'm just going to pull out the key for this one because most of you guys did fine on this question. So to save a little bit of time, I'll just pull out what I have. So my small curve has a mean of 60 and a standard deviation of 15. So if I finished labeling this, it might be easier to see that if she finished in 75 minutes, that leaves 16% that took longer than her. And then on the large one, we have a mean of 180 and a standard deviation of 220. So if I have all of my things marked, I can see that the amount of people that took longer than her was 84. So this answer is B as in boy. So you just draw the normal curve on this one, label it, and then add up the percent of data that is to the right of Bailey's finishing time. Okay, your access code for this retake is SNOW. SNOW in all caps. Your access code for the retake on this is SNOW. Number one went pretty well. The only mistakes that I saw were always make sure that you label your normal curves with the parameters. Make sure that you label with the parameters. All B, C, and D need to have units. B, C, and D need to have units. So B needed to be minutes. C is percent, D is percent. The biggest mistake on letter B was that you gave 95% instead of 99.7. 99.7 is from 10.3 to 22.7. I don't know why I said 22, it's 33, sorry about that. Response times between 14.2 and 25.9 is 13.5 plus 34 plus 34, which gives you 81.5. I know this because I drew out my normal curve, I labeled my mu and sigmas, and then I added up the portions. So this last one was this section, and this section. What response times are greater than 22 minutes? Well, 22 minutes is your median, so it would have to be 50%. And then our last problem is zucchini weights that are normally distributed. They want to know which one of these models from 0.3 pounds to 1.05 pounds. And on this, you should just use the x-axis as a formula to figure out what this value is. So mu is 0.8, and they subtracted 1 standard deviation. So that gives you 0.55. So it's not A, because your lower bound is 0.3. Mu plus 0.55 standard deviations, so this is 0.8, plus 0.55 times 0.25. If I plug that into my calculator, I get 9375. So it's not B. This one is mu minus sigma, so it is also 0.55. So it's not C. By deduction, it has to be D as in delta, but let's check. 0.8 subtract 2 times 0.25 does equal 0.3. And 0.8 plus 0.25 does equal 1.05. So it is D as in delta. So our passcode is SNOW, all caps, SNOW. Remember to email me and let me know you're ready to take your exam, and I will make it available to you in Canvas. As usual, if there's anything on this quiz that is still confusing or not clear, email me or come see me, and let's get it cleared up before you do your retake. All right, I think that's it. Love you guys.